Hopefully this is working. Okay, so this is sort of chapter 2 of the AS mechanics, and it's going to be quite a short, it's going to be in 2 parts. So this is part 1. Part 2, we're going to look at connected particles and pulleys, but that in itself is quite a long chapter. But in order to get there, you have to make sure you understand force diagrams, a lot of which you'll have come across at GCSE, but then also in terms of vectors. So let's take a general force diagram. So if we have, say, a block going down, you're going to have its weight. And weight is always mass times gravity. And in maths, in mathematics, we use 9.8. If you do physics, you might use 9.81. All right. And then whenever you've got something sitting on something, you also get what we call a normal force or a reaction force. So you might see it called N in places, but it's just the force that resisting the block sort of sinking into the ground. You might get some friction or some resistance forces if we assume it's going one way, and then you might get a pulling force. Now that could be tension, it could be in a string. So we consider the block to be a particle, meaning it's a point with no dimension, so that doesn't affect it. And Newton's first law tells you that an object stays at rest unless there's an unbalanced forces. So what we're going to be looking at is what we call the resultant force, not to be confused with the reaction force. So the resultant force is exactly like the name suggests. It's the result of the forces and how they act. So forces have to be balanced in all directions. So up has to equal down, left has to equal right. So if we have a look, let's just take a particle. Say we've got 40 newtons going this way, 40 newtons going this way. We've got 40 newtons going upwards, but only 5 newtons going down. Now my resultant force, the way we word it is we say we resolve. So I'm going to resolve up and down. So I'm going to say up, take away, down. So I'm going to get 40 minus 5. So my resultant force is 35 newtons going upwards. Whereas if I look at it horizontally, I've got 40 take away 40, which is 0 newtons. Therefore, this particle is accelerating, it's going upwards. So actually, the only force, the resultant force is 35 newtons going upwards. So that's sort of a very quick idea about what resultant forces are. Let's just take one more diagram to make sure you've understood that. So let's take a particle. Let's say we have 10 newtons, 7 newtons, 4 newtons, 1 newton, and let's say we have 8 newtons. Okay, so now if we want to think about this is a little bit trickier. So we're going to say, okay, what is my resultant force? So let's go upwards. So going upwards, I'm going to have 8, which is going up, minus 10, which is going to give me minus 2 newtons. And going this way, so going towards the right, I'm going to have 4 newtons plus 1 newton, plus 1, minus 7. So I'm going to end up with 5 minus 7, which is actually minus 2 newtons. Now, if I think about it, what's happening? That means it's like it's going down 2 and this way 2. So actually, this is what my force is. So the resultant force is acting in that direction. Now, you don't need to worry about what the angle is or the magnitude or anything like that at the moment. We'll look at that in a second. The other way that you'll be asked to add forces is using vectors. Now, vectors you will have already come across. So you'll either have come across them as a column. So we could have 2, 3. The other way that you'll see it written is 2i plus 3j. So you'll either have an ij notation or a column notation. It doesn't matter which one you use, as long as you're consistent. And if it gives you the question in IJs, it's probably good to answer in IJs, because then you'll be able to match it up easily. So the way that you might be asked this is you might get told, let's have a look. So we've got 3 forces or 2 forces, and normally you're told about forces acting in equilibrium. When something acts in equilibrium, it means the resultant is 0. So let's take a previous exam question. So this is from the old Edexcel mechanics spec. And say we have one force and it says it's 7i minus 9j. We've got force 2, which is 5i plus 6j. And these are all newtons. And we've got force 3, which is pi plus qj. And we're told that all these forces are in equilibrium, and we need to find P and Q. So what that tells you is if the forces are in equilibrium, the resultant, so the result of adding them all up, equals 0. So we know that F1 plus F2 plus F3 equals 0. If it's easier for you to see, I think it's easier and people make less mistakes if they do it like this. You can write them as columns. So we've got 7 minus 9, 5, 6, and P and Q, and that equals, well, it equals 0, 0, so equals 0. So the top line equals 0 and the bottom line equals 0. So we get 7 plus 5 plus P equals 0, and we'll get minus 9 plus 6 plus Q equals 0. If we rearrange the top one, we end up with P is minus 12, and if we rearrange the bottom one, we get Q is 3. So now we've got our force. We've got our values of P and Q, but that's still not my resultant force. My resultant force is the result, so adding them all up. So you would obviously rewrite this, but I get the advantage of doing this and putting in the values. So we said P was minus 12 and Q was 3. That means when we add those up, we get 7 plus 5. So we're going to have 7 plus 5 minus 12. Sorry, that's my resultant. This is my check. Sorry, 0, 0. Right. Now they're telling you F3 is removed. So now we've got rid of F3 and we want to find our new resultant. So we're going to get rid of F3. So F3 is gone. So F3 is gone. What is our new resultant? So now it's not going to be in equilibrium because we've only got these values here. And what does this give us? So our resultant now is these two together. And that's 7 plus 5 to give you 12 and minus 9 plus 6 to give you minus 3. So that's now our resultant force. If that asked you to find the magnitude of that, what does that mean? So you probably would have come across this before. So we've now got 12 minus 3. So if we think of an axis with I and J, means we're going across 12 and down 3. So it's in this direction. So that's 12, that's 3. And we want to find the magnitudes. The magnitude is the length. So hopefully from that diagram, you can see that you're going to be using Pythagoras. So this is my resultant. And the way we represent the magnitude is with these goalposts. So with the lines either side. So the magnitude of R is going to be the square root 12 squared plus 3 squared, which gives you the square root of 153. And because we're in mechanics, we're going to use values. So we get 12.4 newtons. So when you're in pure maths, you tend to use exact values. And when you're in mechanics and stats, you use decimal places. But that doesn't represent the whole force. We also want to find out the angle. And the question actually asks for the angle that it makes with J, okay? So it's looking for this angle, but the angle that's easy to find is this, because we've got the opposite and we've got the adjacent. So we know that tan, let's call that theta, tan theta is 3/12. So theta is going to be inverse tan of 3/12, which gives you 14.03. So that's the angle that it makes with the horizontal axes. So the angle it makes with the J, so angle with J must be 90 minus 12.4 newtons. So that's this one here. Now, if it said the positive J, sorry, it's called positive J, you would want 180 minus that, actually, 14.03, which gives you, yeah, sorry, not positive. So let me redo that, apologies. So 14.03, hopefully, is my answer. And that's the angle, I read the question wrong, it was with the I, so we don't need that one, we can ignore that. So theta is just 14.03. If it wanted it as a bearing, remember that's 3 values, it would be 0.14. And in this case, it doesn't. Right, next question. So we've got, all right, forces which are parallel to something. So this comes up in the vectors unit. So on a straight line XY world, so in your XY world, if 2 lines are parallel, they're like this. So their gradients are all the same. So the M is the same. In a vector world, if I have IJ, and this is what you need to understand. So if I have, say, 1, 2, means I'm going 1 across, 2 up, that's 1, 2. So that's vector 1, 2. If I had the vector 2, 4, so 2, 4 would be 2 across and 4 up. It's going to go on the same line as 1, 2. That in vector world is called being parallel. So if a vector is parallel, it's a multiple of it. So when we're looking at vectors and we want to find out if things are parallel, they've got to be multiples. So if I give you 2 forces, for example, so if they gave you F1 is I minus 3J newtons, F2 is, oh, they don't give you F2, they tell you F2 is Pi plus 2pj newtons, but they tell you that the resultant is parallel to I. Okay, so first let's say, how do we get the resultant? It's going to be F1 plus F2, which is going to be 1 minus 3 plus P2P. So we're going to get 1 plus P and minus 3 plus 2P. And we know that it's parallel to I. So what does that mean? If I've got I and J, we said it's effectively going to be on here, which tells us what is 0, which bit is 0. Well, we can see along this entire line, your J component is 0. Your I is constantly changing, but your J component is 0. So this bit is equal to 0. And that allows you to find P, which gives you 3/2. So that's the first bit of forces. So the first bit is to understand the concept of resultant. We then come to Newton's second law. So the nice thing is, compared to physics, you don't need to remember which bit is which law, but this is really important. You need to remember F equals ma. And the important thing is this is the force, and it's in the direction of A. So the net force, this is your net force, so your resultant force in the direction of your acceleration, okay? So F and A have to be in the same direction. Okay, so that makes sense though, doesn't it? So if you're going to do something to the acceleration, if you're going to double the acceleration, if you double the force, you'd expect the acceleration to double. If the object is twice the mass, you require twice the amount of force to make it go at the same rate. So this is a super important equation. You're going to come back to it again and again. Now, in terms of notation, when we represent forces, we're going to represent them with an arrow in the direction that they're going. And when we represent acceleration, we're going to represent it with a double arrow. It's just good practice. You're not going to lose marks for not doing that, but if you get in the habit of it, it's a good practice to have. So let's think of an example. So we've got, let's take, sorry, just pulling an example up. Let's take a car of mass 1,500 kilograms, has a driving force of 800 newtons and forces of 120 newtons resisting it, resisting the motion. And you have to find the acceleration. So step one, draw yourself a little diagram. Even if it's wrong, you'll get marks for the diagram. So you've got your mass here. So I've got my particle here. What do I know is acting on is a driving force. So it's going forwards, is 800 newtons. Against it, I've got 120 newtons. I do have 1,500 G going down and a reaction force going up. But because I'm looking for the acceleration, all I care about is the forces in the direction of acceleration. Now, acceleration is going this way, so it's going in that direction. So anything going in the same direction is going to be a positive. Against it is going to be a negative. So my F equals ma, my net force is going to be 800 minus 120. My mass is 1,500, and I want to find out A. So 800 minus 120 gives me 680. A, and if I divide that by 1,500, I get my acceleration as 0.543 meters per second squared. So that's the first bit of forces. So you've got resultant forces, and then you're using F equals ma. We then move on to look at it combined with some Suvat equations. So F equals ma involves force and acceleration. So it allows us to connect all those other calculations that we did with Suvat with forces as well. So if you have a body, so this comes from the EdXL textbook. So you've got a body of mass 5 kilograms is pulled along a rough horizontal table. A rough horizontal table by a force of 20 newtons. Friction is 4 newtons. And you've got to find the acceleration. So you want to find A. You want to find the distance traveled in 4 seconds.